And we're live. Hello,
Hello,
everyone.
everyone.
Apologies for being late. What's funny is that we're 5 minutes late, and I just wrote 3 minutes. 2 minutes ago, I wrote that we were 3 minutes late, and it went so fast that I'm actually surprised that it's not 3 minutes anymore, but five.
It's
But
totally on my side, so sorry, guys, about that.
well, not quite. Maybe you would be more prepared if I didn't send you the link a minute before the webinar, which is my personal universe of relative time. Anyway, with that in mind, we wanted to welcome you very much on the second part of our webinar into JavaScript performance. The idea for this webinar is very simple. We made the guide, the ultimate guide to React Native optimization. And during those webinars, we're going through different parts of that guide on some real examples. The guide has three parts. The first one is JavaScript. Then we have React, native, and native. Actually, native, React Native, and bundling. That's correct. Um,
True.
so we have those three parts. I always keep using the previous year's edition content. Anyway, we have those three parts, and the idea for the webinar is that we will be going through each part in the future webinars. So if you're interested in native or bundling or anything concerning putting your application to the App Store, you should sign up or follow us for future releases. Today, with Shimon, we will talk about JavaScript, the first part. And again, if you have missed the previous webinar where we went through pretty much half of it, it is, or if not, it will soon be on our YouTube channel as well, where you can watch it. Today, we will resume whatever we finished. And with me today is Shimon, who is our developer at Callstack. He's, expert, everything concerning React and JavaScript. He's been working on some really exciting projects. So maybe as a way for him to introduce himself, I'll let him tell you a bit more about the things that he's been working on lately. Also regarding Expo, I think you might be interested in that as well. So Shimon, over to you.
Hmm. How to sum
An
up?
intro, right?
Yeah, I mean, how to sum up myself in a couple of words, in a couple of sentences. Yeah, so my job is about not only creating stuff, but also validating whether other teams made a great job in the past by basically going through different code bases and looking for any performance issues, and then uh, creating those audits, documents, performance audit document you can go through and basically find out what's wrong in your code, in your app, and then, well, fix it yourself or just use our help, Callstack's help to make your app better. Um, so you mentioned my, let's say, additional work, my side projects. So lately, I've been working with React Server components, which currently I think are only supported in Expo, but my work is not really based on Expo at all. So I'm working on bringing React Server components to, well, React Native itself without any frameworks included. We'll see how it goes. Pretty far into it, so I keep my fingers crossed I will manage to finish it by the end of the next month, let's guess. Uh, but now let's go into the topic of this meeting, of this webinar, so JavaScript performance. So for those who are the first time there with us, we have this React Performance Honeypot app, which is basically a playground when we can go through different performance-related problems originating from JavaScript itself, because now today we are focusing on JavaScript, and we can go through all those examples and basically see what the problem is, what can you do to basically fix those problems, how can you look for, let's say, root issues, how can you debug your application to make sure it works well, performant, that it works fast. So, to be honest, I'm not that much sure where we finished last time. So maybe let's start with the first section. And I believe we did the synchronous work. Um, I'm not sure if we went through memoization for debounce. So if you can let me know in the chat if we were there. If not, I will just get into it and show you what the problem is. So what I said is true. I frequently have to go through different code bases, old ones, pretty new ones, and many of those code bases suffer from the same problems. And those problems are basically what drives the current webinar, I would say, because all those sections you see in the Playground app are basically um, driven by my experience with those audits. So, without further ado, let's jump into debouncing. So, in the nutshell, you probably know what debouncing is, but if you don't, then let me just define it in a couple of words. So, sometimes we have cases when users can, for example, write quickly in a search box. And the problem is that if we have to use whatever user has written into the search box to filter some rather long list, we may end up in that situation when JavaScript cannot hold up. We can have multiple, like thousands of elements to filter. So usually what we do, we debounce those events. So we wait until user basically finishes writing. So let's say I will write something really quickly, and you can see that there are many search operations being performed. And you can even notice that there's some delay between my keystroke and search operations performed text being updated from the React Native side. So usually what we do in such cases, we apply debouncing. So instead of having those hundreds or dozens of operations, search operations, we basically have one of them when user stops writing. The problem is that sometimes, or not even sometimes, but often this debouncing is implemented in the wrong way, which basically breaks the whole debouncing. So um, I have a simple debounce function. You probably used debounce from Lodash library, uh, but it's pretty much the same thing. You have some sort of timeout with some sort of waiting time, and as long as debounce function is called, this timeout is reset and start again. So as long as you are typing, nothing happens. And of course, you need to wrap some function in this debounce thing. So in my case, I have my handle search function, which is basically debounce of this particular implementation, which is fairly simple. Now, the problem is that debounce will create a new function every time we call it, because debounce is supposed to be called only once and then reused. But sometimes people uh, forget about it. Usually, people forget about it. And in the end, debouncing doesn't really work. You basically uh, trigger the same function, the search function, multiple times over the time instead of calling it once. So I'm kind of referring to the main topic of our last meeting of memoization. When we need to apply memoization in the correct places, there were many questions regarding if we are supposed to memorize everything or just some particular functions. So to recap, my approach was that there are certain patterns, certain functions you always need to memorize. For example, if you have render item in your flat list, flash list, or whatever list you use, you always need to memorize render item to achieve the best performance possible. And the same applies to debouncing, because if I memorize debounce function or whatever comes from the debounce function to be precise, my search operation will be called only once when user stops writing. And as you can see, well, the performance is okay. I wouldn't say better because it's it's a workaround for not being able to catch up. But still, it's better than overloading JavaScript with filtering operation. Um, we are running new architecture, so things are a little bit different. But if I turn this application back to old architecture, you will see even worse results. You will see my search input becoming desynchronized with what I write. You would see, for example, the cursor moving back in text because JavaScript couldn't catch up with the events, and because of the asynchronous nature of the old architecture, we would see this kind of desynchronization. But with new architecture, it's not that really it's not a problem anymore. However, you still see that with my non-memoized example, there are too many search operations being performed, and with optimized example, I can write something, stop for a second, then start writing again, and I will only see 3 operations performed, not thousands of them. So that's a quick recap of what we learned last time. Mhm. This time, I want to also show you some, let's say, patterns that you can apply in your projects to, for example, limit the number of re-renders of components being re-rendered all over the time. So I have a simple example, mm, which I basically took from one of the projects I worked on in the past. So the case is simple. We have some sort of tab bar. We can switch tabs, and there's some content that's reacting to the tab being active. When I go to profile, I will see profile content. When I go to home, I will see home content. Nothing spectacular, nothing surprising. It just works. Now, the problem is that depending on how we implement that, we can stumble upon many problems regarding the performance. For example, in one of the cases uh, well, I personally worked on optimizing the component containing the, let me find the example. So in my case, in this real world case, there was a screen, huge screen with multiple components, with many custom hooks, with state variables, with Redux selectors, with effects, many complex hooks, components, and so on. And the problem this app was experiencing was that when you clicked on some some button in the tab bar, it will change. It will change, let's say, immediately, but the content would be delayed by, let's say, hundreds of milliseconds, or the other way, depending on the implementation. So when I went into the code, I noticed that there's so many components, so many hooks, and the problem was that when you change the active tab bar, you basically change the state, and this state needs to live somewhere. You cannot place state nowhere. So the usual thing is to use state hook and put the state in the common parent of both tab bar and the content uh, uh, that will be changed according to the value of the tab bar component. And well, the problem is that now when you change, when you want to navigate to different screen, different button in the tab bar, you will basically force the whole parent component to re-render with all the hooks, with all the components, which can be pretty much demanding for the device. So what you can do about that? Of course, you can use something like, for example, Zustand, Yotai, or whatever a state library you use. I wouldn't say Redux is the best case there, but those lightweight state managers are very good um, candidates to be used in such case, because then you can simply move out the state from this parent screen and just subscribe to the changes in components needing the latest value. So in both tab bar and the tab viewer, let's say. But the truth is that you don't need Zustand, you don't need Iota, you don't need any external state manager. You need to know how React context works. Because a quick recap again, we talked last time about React context. So React context allows us to inject JavaScript values, arrays, objects, strings, numbers into some components nested deeply into the component tree without passing the value component by component by component by component without prop drilling. And all those components that are subscribing through use context hook to the context provider will be rendered whenever the context value changes. So we can use this characteristics of React context for our use case. So again, let's go through the example. Let me double check that's the correct one. This is the correct one. Sorry, the last one was about something else. So we have our context rendering screen with two examples. So with two components. One is tab bar with context, one is tab content. So if we go to tab bar with context, you will see it's basically a context hour wrapper over tab bar, which is a simple component accepting active tab and notifying parents through on tab change callback about changes. And this component, this tab bar, needs to access the latest value of both active tab and set active tab to be able to change this value. And we don't want to modify the tab bar itself because it's supposed to be, let's say, simply simple present component used for presentation only, let's say, without no business logic. So that's why we create this wrapper. And the second component we have is tab content, which basically does pretty much the same thing. It taps itself into tab context we have, and it observes active tab because according to what the value is, different content should be displayed. And of course, we need the, let me find it really quick. We need the context itself. Where is it? There is it. So the context itself. State, tab context with provider, nothing special. Tab context created with create context from React. Two properties, active tab and set active tab, and a custom hook just to make it more friendly to use. And now if I switch our view to a different one, to this one, we will go into React Profiler to see the difference, because the difference is here and it's super useful for you all to, to be aware of that. So we have our profiler. I will start the profiling session. I will go back to the app, go to profile, stop profiling. And we have 3 commits. We will discard the first one, the last one, because those are related to the button being clicked, the overlay state. So press was in, so this background changed, and then press was out, background again changed. We should mostly focus on this this big one. So when I go back into tab viewer, so tab viewer is the component we have our context in. Tab bar is obviously a tab bar. This anonymous is this tab bar wrapper with use context. This view is part of, well, basically what we have around our content and our tab bar. So we can have multiple components in here that can be super complex and can rely on many custom hooks. But as you can see, those are not rendering. The only component rendering are tab bar wrapper because context change. That's true. And the second one, which I need to find this one. So the, the tab content, which is also dependent on the context value. So that's why context has changed. This component will be also updated. And it doesn't sound like a huge gain because we have only one component not rendering in the like simple scenario when you use set state and just pass the props to both tab bar and tab viewer. You would expect, well, one more component rendering. But again, this is simple example to just show you the principle, because if you have those huge screens with many components and hooks, you can expect dozens of components not rendering instead of the single view I have in my example. But to prove you that I'm not simulating it, let's add something else in here. Or maybe let's start with questions while I'm working on the changes. So if you can go for the questions, I would be grateful.
All right. So the first question is, how many levels of prop drilling warrants a rewrite into context?
I wouldn't say there's a golden rule for that.
I didn't even know there was a rule unless
I mean, people tend to always create rules for because it's easier to, well, reason about things with such rules. You have to use context when you have to pass some kind of prop 3 levels down. It's simple, you know when to apply it. In reality, it depends. It depends on the use case. If it's something, let's say, if it's something generic, if you have a theme in your app, theme, so object containing, let's say, colors, some spacing values, um, some typography settings. Usually, such global objects are passed through React context because you need those pretty much everywhere. Every UI component needs to uh, tap into a theme to set correct colors, to use correct typography. So for such generic, let's say, reusable objects, I would go with use context in the beginning, even without thinking about the levels of components, of how far I will need to pass my props. What else? Authentication state, for example. Uh, it's also something that's general. You need authentication in many places. You need to, for example, tap into the information about user role in the system. So you can hide certain components or you can show additional components. So I would say such general objects are best candidates to be put into context. Of course, you can also use context in some more specialized scenarios, but I wouldn't say there's a golden rule.
I
As
think,
long as you're, yeah, go
yeah,
on.
yeah, I think I agree with you. Generally speaking, it probably depends also on what these props are, like what is actually being passed down the tree, for example. But I think I personally tend to use context for, things that, like generally speaking, things that are application level. So it's also a matter of design, right? When it comes to a theme or maybe something like that, you don't really need or want to pass that down. But if there is a prop that you want to pass down for whatever reason, say it's a username, and that is specific to a given component, and say you have many level deeper nesting, I haven't seen anybody registering something like a context just for that reason alone. Um, all right. Another question is an interesting one, I guess, because it will touch base on many personal preferences. But um, I think a good question about state management is when would you recommend using Redux or Zustand over React context? And it's an interesting debate, I guess, because there is always this question of you should just use React context. But I think there is more to it. So I'm curious to
Definitely,
learn what's your opinion on that.
definitely, because well, to be honest, I'm not a fan of Redux. I mean, Redux was great back then when there was no React context at all, because we needed a way to basically inject those themes, inject those authentication states, user roles into components living deeply into in the component tree. But right now, with React context, many use cases for Redux are no longer there. React context is not the best option for all, let's say, global objects, because there are certain cases when, uh, say, your state is going to change frequently. And with React context, if you have, let's say, a large object containing multiple values that can change independently. So let's say we have an object with property A, B, C. A will change every second, B will change every 3 seconds, and C will change every 10 seconds. So there may be components interested in only C, there may be components interested in only B, and there may be components interested in only A. But with React context, you basically force all components to listen to all changes to this object. In contrary, for example, to Zustand, when you can implement selectors and you can simply tap into parts of the state. That's also a case for Redux. You also can have selectors. You can also extract just parts of the state you are interested in, and your components won't be rendered without a valid reason. But there are still many, many cases when there things can go simply wrong, and I have an example of that. We will go to later on. So I would say there is this clear hierarchy that you start with React context and you're trying to reason if your data will be changed frequently, if your state passed through React context is going to be large, if it can be decomposed, because if it can be decomposed, you simply should decompose the state and have multiple React contexts. Or you can decide to go with, for example, Zustand. You can create a Zustand store and you can switch to selectors. So, for instance, a real life use case. In the past, I implemented a video player with controls in video state, controls, progress bar, buttons like stop, next item, previous item. And initially, like the implementation was using React context, and it was working just fine as long as I was using iOS. I know, okay, iOS device, because those are usually way more performant than Android. So in while working on it, it worked perfectly. But then when I used some Android device, which is not like top notch, the most expensive Android device in the world, but just some like generic one for 300 $400, it turned out that there's so much of work being done, unnecessary work being done in React in the component tree, because so many components are rendering without any valid reason. Because, for example, uh, my progress bar needs to render whenever there's a change in the progress, but all other components doesn't need that. I mean, they are not dependent on the progress time. So the performance was terrible. But then I switched to Zustand and I basically refactored the whole thing to basically enable this atomic state, let's say. So my progress bar was tapping itself into Zustan store and extracting progress time. So this component was rendered frequently according to the requirements, but all other were basically static because they didn't rely on the progress time at all. And this was a valid reason to use Zustan. I could also use Redux for that, but then usually in the Redux world, we have a single store to put basically everything. So if you have, for example, 6 instances of the same component and you want to use selectors from Redux to optimize it, you will end up with some weird structures in Redux, some arrays allowing you to add new instances of this component. And then you will need to remember to remove those state variables whenever the component unmounts. With Zustan, it's easier. With Zustan, you can create a store dynamically when component mounts. You can use provider, context provider, to inject this store to deeply nested components, and it will be automatically destroyed whenever the component unmounts. So for such cases, it's, in my opinion, one of the best options we have right now.
Cool.
Let's
Uh,
go back to before we go into more questions, let's go back into the example and we'll change the active screen. So some of you may say that I may be not right about the whole rendering thing. So I have this heavy component, which is really heavy because it takes around 5 seconds to be rendered, which usually, when you have such components, usually you end up with, 5 second delays in rendering. So technically, when I press the profile button, I should not see my UI being changed for 5 seconds if my optimization doesn't work. It worked. I can click around and my heavy component is not rendered at all. So this pattern really, really works. All right, and Redux, which is, well, my number one library, which is often used in incorrect ways. Let's say people use Redux, but people doesn't understand Redux at all. Uh, People know that they need to use createSelectors to create selectors, memoize them to uh, have less renders in the components. But people tend to forget that, well, with selectors, you still need to think about whenever your selector functions you write, are stable, so usually memoized, and they often tend to forget that if you do some transformation on data coming from the store, you also need to memorize it, because if you don't do that, you will see what happens. So I think that's this file. So the example is simple. I have a to-do list, which I think, okay, it's super small, but I have to-do list with I think hundreds of, okay, simply 100 of elements. And if we go now into or maybe let's stay in the code for a little bit longer. So I have two variants. One is using memoization, one is not using memoization. Let's start with this bad one, non-memoized, and let the thing change. Okay. So this is the list. Nothing really complex. We have a couple of functions to add new to-dos, to, well, change the state of to-do we press, to change the filter, and to increment some counter also stored in the Redux store. And then we have a simple list of to-do items which accept ID And this ID is then used to extract some additional data from the Redux store. This is usually a case. Often you don't really extract everything from Redux store when you need to render this. You only extract some identifiers, an array of identifiers. So the parent, the container will only render when there is a change in number of items. But then each item will basically tap itself into a correct item in Redux store, and only those items will be rendered which need to be rendered because of some changes. Because if you extract everything in one go in the container component, the whole container will be rendered, and then, well, it depends on the implementation again, but in the worst case scenario, all the components will be rendered without any valid reason. So what can be wrong there? Many things. So let's start uh, with this selector. What's wrong there? Multiple things. So first of all, it's not memorized at all. It's not using createSelector like the second one. So every time something changes in Redux state, this function is called, and then the output is also created uh, from scratch, basically. So each time we receive a different array, which is treated by Redux as a different thing. So if your selector returns something different, Redux will basically render your component. So that's the first issue. The second issue is that, even if there is something changed that's not really connected with to-dos, this selector will be still called. This selector will still create a new array and will cause Redux to re-render the second time. So let me change to my second screen. So we will see it in practice. So this is my profiling. I will start the profiling session. I will, for example, click this increment counter, which, as you remember, is a different state variable in Redux. It's not really connected to the items at all. It's here to cause changes in the global state of Redux. And what happens is that, well, we have many components being rendered because of the change in the store. And as we know, I can even go back in a second. Those components doesn't really rely on the counter. They don't need the counter at all. The problem is that this container component, which is using our select filtered items, is not memoized. It's tapping itself into the global state. So whenever something changes in the whole Redux state, no matter what, the component container will be re-rendered, and the same principle applies to item components, which also are tapping itself into Redux store. But still, because there's no memoization, all components needs to re-render. But if I change to my second example, you will see that the same thing doesn't really have such terrible effects. Because now, of course, we also need to re-render memoized to-do list. Why? Because we have counter in it, which is, well, dependent on the counter property from the Redux store. But items are left untouched because they don't need counter at all. So let's go back into the code and see what's different between those cases. So. Let me find the second example. This one. So, at first glance, it looks totally the same. The name of the selector is different, but we still select filters. We still select counter value. We still have to-do items. Well, the name is different because there's a certain change in the implementation, but we'll get into it later. But what's important right now is that with select filter to-dos, we use createSelector. What's the difference, you may ask? Well, the difference is now that we only select to-dos from the state and we only select filters. And those selectors are simple. They don't transform values. So if to-dos change, their value will be changed. But if to-dos doesn't change, if this property doesn't change, the value returned by this selector will be the same. And when you use createSelector from Redux, you basically tell, let's say, you tell the Redux that if one of those selectors return a different value, I need this selector, my custom selector, to be rerun because something will be probably changing the output. So that's our first change. And then when we go into this one, because okay, so this is the one used by a previous example, which is basically get me a to-do by ID and then transform it, which is again a problem because first of all, this part will be constant. Let's say if to-do number 1 is not changed, this to-do will be the same. Simple. But if we transform things, this outcome will be different, no matter if to-do was the same or not, no matter if to-do changed or not. As long as this selector is called, a different value will be created, and Redux will basically cause our component to re-render. So the change is simple. This time, I again use the createSelector. I have an additional selector which takes the to-do from the to-do list, because we know that if to-do, if a single item didn't change, the output will be the same. So this one is fine. So this selector will look at this one. If something changes, if to-do changes, we will transform. But if to-do stays the same, we will not transform. createSelector will hold the last value of our selector and will return it on every call. And when we go back to the code and look for our new item, which was also a little bit updated, we will see that. Yeah, that we use the new selector. And if I go to the okay, so I can maybe show something else there, because
What is the speed, Shimon, by the way? What is the speed difference between using this versus using, let's say, it's hard to compare with other state management, but at the same time, when I see the number of selectors and memoization, I'm starting to think, is there a performance implication I should be concerned about or not really?
about performance implication of using so many selectors and so many memoization
Yes.
in those selectors.
Yes. But I know the answer is probably
It depends.
yes. I
Well, technically, with Redux, with memoization, your components, if they need some kind of transformation, they can do the transformation themselves inside of the rendering, let's say, process. But if the state doesn't change in any, let's say, valuable way, because transformation may discard some part of the information, and if this part changes, we don't really care about that. So if we don't memorize the selector, we will have our component re-rendered, and it will happen without any valid reason. So it's something for something. You need to trade something to get something.
Yeah.
And it applies to pretty much every state variable, or sorry, any state management solution. The same applies to Zastant, for example. You still need to write selectors in a good way. you still need to pay attention to that. Think maybe it's a bit different in those state management solutions based on atoms, but there are different set of problems present, and you still need to kind of think about how you structure your state. Because if you, let's say, do it in wrong way, you will end up with way less performance application, but that's not the best timing to talk about how to structure your state in your application to, well, to have it perform in the best way possible.
Yeah, makes.
Um, yeah, and what I wanted to show you is that when I now record it again, and I will add a single to do, so we will expect the container to be rendered because there's a new to do added, and then we will expect only a single to do item component to be rendered because others stay the same. And let's see if that happens. So I scroll down. The container is changed. That's what we expect. And now I'm trying to find this one, but it will be hard because it's super small. But you can see for a second when I change the width that there is this last component, which for some reason is going out of my out of view, and I can't really scroll through it. But you need to trust me that there is a single component um, render inside. All right, so we are done with this part. Let me go back to the comment section. There's anything else? Anything new?
I think there are some questions regarding the previous pieces that we had back when you were showing the when we discussed the prop drilling. So, but they seem quite low level. So let's see. If we maybe could, Shimon, pull up the whole screen where we have different examples in the app.
Mm-hmm.
Now that we have around 10 minutes left, we have animation and performance, concurrent React, the state management we discussed, the memory leaks we discussed. Maybe there are any questions or things that you'd like to see before we start wrapping this up.
I would recommend going with concurrent React features because those are sometimes misunderstood and that can lead to, well, many problems if you don't understand what, for example, well, what concurrent React is. Because
That sounds
sometimes
like
they,
that sounds like a topic for yet another one. But
it
with
will
that,
be quick, I promise.
I
I have
mean,
it.
we should do. I mean, I'm down for that. So let's do it. But meantime, in the meantime, you guys please leave questions in the chat. If there are any questions that remain unanswered after we finish, we will be reaching out to you. So please do this. And in the meantime, maybe we can, yeah, let's quickly go over what we have on the current React side.
In the nutshell, uh, in new architecture, you have access to concurrent React features to hook like use transition, use deferred state. And I think there's a third one, but I don't really remember the name. So let's say there are only two of them important for you. I wanted to focus on the second one on use deferred value because that's something you may use in practice. Of course, the same applies to start transition, but usually when I see any examples of concurrent React features, those revolve around lists, around filtering, for example. And that's why I wanted to focus on the same example of a list with, well, items, many items with many components inside. So those can be treated as maybe not super complex to be rendered, but still they can take some time to be rendered. And what you probably know, but if you don't, let me do a quick recap. So the way how React works is that it needs to recreate your component tree from scratch every time you do some state changes. And then it needs to compare the old tree of components with the new tree of components and apply any changes. And before the concurrent React, if there's any state change, let's say inactive, so when you change something, rendering process is started and then it must finish. There's no way to kind of say, okay, I'm no longer interested in this change. Because, for example, the example with search box is perfect. So if user types letter A and the rendering process is started, it takes, for example, in the worst case scenario, let's say 200 milliseconds. But then user types, I know, T. So we no longer kind of need the A rendering because it's no longer relevant. Now we need AT. In the past, in such case, um, we would have we would have to wait 200 milliseconds for the rendering process to be finished first, and then the second rendering process to be started, and so on, so on, so on, which could result in a terrible performance, in terrible user experience. So the concurrent React, uh, the main point of concurrent React is that now you can have some, let's say, low priority updates, and those low priority updates can be canceled and be interrupted. So when user clicks T and you have AT in your search box, the A rendering can be halted because it's no longer relevant, and new rendering will be started automatically by React with AT, which is great. So in practice, again, I have my list with many, many items. I have my search list. And when I think I checked that. And I think when I change between 12 and 1, you can see that my current search goes out of sync with the value in the text box. Like the delay is noticeable. It's not greater than a second, but let's say around a second. Why? Because, well, React has to spend some time creating the new tree and basically comparing changes. So if I now switch this toggle, which will use concurrent React features, which will use deferred value, you will see you need to pay attention to current search and the deferred value. Those two will now become desynchronized, but that's good, and I will show you why later. So now you can see that the current search is always updated like immediately, and then deferred value kinda follows after some, let's say, some time. And that's basically it. The current search value is a high priority state change. So this one cannot be interrupted, and this one will be executed first. But then React will start a second rendering, low priority rendering, and this rendering can be stopped if there is no longer need to, well, finish it. So when I quickly change the value, I'm not sure if it'll be hard to notice, but technically you should see that my default value will not follow my current search value by value, but it can switch between, for example, 13 to 1377. It will skip 137 value because, well, it's no longer needed. And now let's go into the code. So you will see how it works in practice.
Mm. Meanwhile, there is a question regarding where is this code available, and we had this question before as well. Wanted to say that it is not publicly available, although judging by the number of questions, we could open source it. But I know Shimon is hesitant because he has vibe coded it. Anyway, um,
You can even see uh,
yeah,
one
if
of the examples being created
if you're interested in that, we'll reach out to you. So please, let us know instead of giving thumbs up, which we do appreciate. Just say I need this or I want this, and we will send you an email after the webinar. Um, and
All right, so maybe
please,
a minute for me.
yes.
Uh, immediate search, so the search without any concurrent features. It's basically filtering stuff, displaying it in a scroll view. That's intentional to, well, to put more pressure on the device. And if I go back, you will see that search term is passed, items property is passed. Search term is basically search term. You state nothing special there, and the search term is set from text input. Nothing special there. We have a second, let's say, deferred search term, which uses the new concurrent use deferred value, which starts with the search term value. So initially the value is the same. And now the difference that with deferred mode, with concurrent mode, what happens is that when you change your search term, sorry, when you change your search term, this one will be updated immediately, but this one, the default value, will hold the old value first. So when you call search term, this value will hold the new value, but this one will still hold the previous one. So my so let's say search component is memoized. So the same search term, the same items, nothing will be rendered. So the priority render, the render about the search term will happen immediately because there is not much work to be done. But then React will kick off a second rendering process, this of lower priority, and this value will be basically updated to match the search term. So this time, this value is updated. So this value is updated. So my default search will be also rendered because, well, search term is different, and memoize works like this: that if any of props changes, the component is rendered. So people tend to misunderstand it and think that no matter what I do in my components, how complex those are, concurrent features will always help me, and my application will stay responsive and fast, which is not true. Concurrent React features will only help you when you have many, many, many complex components. By complex, I mean components having components, having components, having components. So there are many components rendered. Some of them really nested, many levels. And then React can basically say, okay, I'm done. I don't need to follow this tree. I can start over because the value has changed. But it doesn't mean that you can do whatever you want inside of those components. Because, for example, if I do something not pretty, let's say, so I will force my component to synchronously wait for a second. So while rendering, this component will take around a second to be rendered. So one may think that concurrent React will stop rendering process and start over. Let's make it 5 seconds, just to be honest. One can think that concurrent React features will basically make this whole thing work. That no matter that my components need 5 seconds to be rendered, somehow it will just work. But the reality is different. The reality is that when now I will try to have those, it's even worse because now each list item takes 5 seconds and I have 100 of them. So it will take some time. But you can clearly see that if my components include some heavy synchronous work, if I have arrays to be filtered with many items, if I have some huge strings to be created, if I have some number manipulation, like complex number manipulation, some 3D logic, for example, to be executed during rendering process, concurrent React won't help you at all. And that's something you need to remember, that it's not a way to basically work around problems with your components doing so much synchronous work that those uh, well, that the rendering process is slow, those concurrent features help you with your huge component trees, because React will go through each component, and after the work for this component is done, it will basically check whether there was a new rendering process started. So if there was a new rendering process started, React will basically stop rendering and start rendering the new tree. Or if there was, well, if there was no changes, React can continue. Yeah. So that's it. That's what I wanted to show you about concurrent React, because I have heard so many times that you can do whatever you want. You can always uh, put heavy logic in your components, and concurrent React will be there to help you. No, concurrent React will most likely not change anything in such cases. It will help with huge component trees. It will not help with synchronous work.
Thank you, Shimon. That was very quick, but very insightful deep dive. I think um, the last question we can ask here to wrap up this concurrent part was around using it's kind of related, was about using single threaded or multi-threaded multiple threads. It is not related perhaps to the React part, more to the React Native part or worklets in that sense. But I guess maybe we could briefly talk about it for a minute, and then 10 past 10, we wrap it up.
I just killed my app. It took me to the start off. Um, yeah, so background thread processing. I have something prepared for that. Worklets. So technically, when you work with React, let's say React Web, you have, let's say, additional threads. You have web workers you can use. You can pass data to web workers. You can receive data from them in your main thread, and therefore you can offload heavy logic to different threads, so your application will stay responsive all the time. In React Native, we have worklets, which are, well, similar but different concepts. They also are used to kind of offload heavy logic from our main thread, from our main, uh, let's say, main engine for our logic, and to offload them to some additional engines, so those can be those worklets can be executed in the background without harming the performance of our main thread. And not many people know that worklets, which are usually utilized by Reanimated, by Vision Camera, by, you know, probably what was the name of this library for graphics? Skias? Uh,
Skia, there's also like
Skia?
GPU with a lot of cool stuff.
Okay, so Skia, I think I'm right about that. Skia utilizes worklets too. But not many people know that you can utilize worklets in your own code. Because sometimes you have some heavy logic, heavy synchronous logic, because that's important, that needs to be executed, and you don't want the app to well, become frozen. So I have some logic in here that basically simulates decoding a base64 string, which is really huge, like 18 megs of base64 code. And when I click decode sync, it will be decoded on the main thread. And as you can see, if I click counter, nothing happens until the characters gets decoded. Then the counter basically jumps from 0 to 12. But if I use worklets and I start the same work in the background, I can click, and React is free to update stuff in the main thread, because my work was moved out to a secondary thread, a worklet thread. Okay, a minute. I would just show you how it's done, because it's super simple. Not this one. This one, not this one. There are too many of them. This one. So you have something called create worklet runtime, which can be, well, imported from React Native, reanimated, and can be used in your code. So you create a worklet runtime. And this is basically a secondary JavaScript thread. And then you can use run on runtime function to basically use your newly created worklet runtime and execute some worklet. The code base 64 is my worklet because it has a worklet directive. And then at the end, I simply use run on JS to basically pass information about what I decoded back to my main thread. So call on finish callback I provided. And that's it. It works. So if you have, in some scenarios, when you really need to do synchronous work, you can use worklets to keep your app responsive and spend some time on a secondary thread to compute what you need and just pass the result back.
Thank you. That was, I know, very short, because I know that, when it comes to performance, you could probably talk for way longer, especially when it is regarding, the samples that you have here. And it's funny that we planned to do this one in like 30 minutes or 40 minutes, but we did twice as that, which is also interesting. But I guess, the fact that everybody stayed for so long means that this topic is very important, which is great. But at the same time means that we might need to do these more often, uh, which is something, you can keep in mind, as we will be posting about next webinars, as well as doing more live streams in the coming weeks on other pieces of Ultimate Guide, as well as other pieces of our open source libraries. So I guess with that in mind, I wanted to thank you, Shimon, for doing this. I think it's amazing how you can talk about performance for an hour.
It was a pleasure.
And it's it's interesting. I mean, it's like you start diving deeper into those performance topics, and then we can all see you fly away with these, which is fun. And thanks everybody for being here. And I think if you have any questions to me, Shimon, or performance in general, um, it is good time to leave some questions now, or after we end the stream. The chat should still work, and we will be in touch with you. And also, we will let you know when we do a next one. Next one might be regarding native pieces, a interesting break from what we discussed so far. Shimon, any closing words from you?
Well, JavaScript performance is important because we mostly write JavaScript. So if you know how to write JavaScript in a performant way, you are most likely to have a performant application in the end. So my closing words. That's it. Thank you for being here in so many. Yeah, thank you for being here in so many in huge numbers, because we had 170 people or over 170 people listening. And I will try to make the app, the source of it, right. I will try to remove any hallucinations of Claude Sonnet I used, and then I guess I will publish it at some point. You will obviously receive a link to the repository as soon as it gets published. We have a way to contact you all through emails, so we'll just send an email. You can expect it in, I wouldn't say a week, because now we have around 3 days of 3 days off, because majówka, so to say. But I would say 2 weeks, maybe 3 weeks. 3 weeks. Let's say 3 weeks. And we will see how it goes.
Exactly. And one thing I will say is that if you have any questions, or you need help with performance in your application, this is my email. If you text me, I will also forward your questions to Shimon. You can also visit Callstack. We do performance optimizations and anything React Native specific. So if you need help with React, React Native at your work, or you're starting something new, let us know. We'd love to learn more and see if we can help you, or at the very least, have a conversation like this one where we can help you adapt React or React Native. So, with that in mind, it's beautiful day ahead of me because I'm in San Francisco. For you, Shimon, not quite, right? Because it's getting darker. But it was fun anyway.
It's still light enough to go outside
Yeah.
and have a walk.
I can show the proof as the city. It's so we're working around the clock.
Exactly.
But
All over the place.
once again, thank you so much for doing this, and thanks everybody for watching us live. And till the next time,
See ya.
bye.